Hello, I'm going to go through the Canvas project a little bit with you, just kind of give you some hints to help you get started. Hopefully it might get somebody through some of the difficult conceptual ideas of the project. I'm not going to work anything really out for you, but I just want to talk about the different parts. And so the first thing I realized in part one here is what we're actually doing is that we're taking a rectangular sheet of material, whether it be cardboard or a piece of paper, whatever it may be, and then we're going to fold it into a prism. And so by making a rectangular prism here, a three-dimensional view of that, you have to see that from the 2D view on the project. And so we cut out this X portion from each corner. And when you do that, you fold up the sides. And so this portion right here in blue is going to be left over. And so that portion right there is going to fold up. The dotted line is going to stay connected. The other sides are going to be gone. Let me actually show you how this portion right here is going to be gone. And so if you see that blue portion's folded up, that ends up being a side of the rectangular prism. And so that might be a better representation of what their side comes from if I get rid of the other parts of the drawing. And the same thing's true the other sides. They're created from cutting out the X. I think it's a square that's stated, an X squared from each corner. And then we can do the same thing up here. And so the blue portions are going to be the sides of the rectangular prism when they're folded up along the dotted line. So the dotted lines end up being like the folds. And so hopefully that gives you an image of where we're at. And so we need to find the volume. And so they need to think of how do you find volume of a rectangular prism. They need to think of how to represent those three parts. Volume is length times width times height. So how do you represent these three parts in this drawing? And that's where some students are struggling with the relationships, connecting the math, relationships of the sides to these variables. So this is how you build your equation for your volume of that rectangular prism. And the next part, that's writing the function v. That is your function. The real world domain is part B here. Real world domain, when you say domain is the x values. You should know that mathematically, but there's two parts to it really. The equation is one way of thinking about what works for the equation mathematically. And for your equation, anything is going to work mathematically. But in the context of the problem, you have to think about what x is. And when you think about the original setup, what x is, what could you actually use for x? What numbers could you use for x? And so what are you actually doing in the context of the problem? If you're making this actual prism, what does x represent? And then what numbers could represent for that value? So that's the more difficult part, is what's the range of numbers that would work for the domain, that for the context of the problem. Then C, you're actually going to graph your function, but you only want to graph the domain. So your x values, your domain will tell you the different x values to use. So your domain will give you your x values, plug them in to find your y values, sketch a graph, and then from that we can end up finding the maximum later on, which is here. So part two is asking a few general questions about your equation. So what are your labels on your graph? And so you talk about what is the x value, the part cut out, where's that out on the graph? So if you want independent and dependent variable. And then this is actually just plug and chug for C. It's just kind of checking a point or testing a point. So plug 4 in for x. Find f, the function f at 4 inches. So what would be the volume if it was 4 inches you cut out? Then D is opposite, if the volume. So if f of x was 1,140 cubic inches, so inches cubed, what's x? So then that's the second problem. And then E, we want to actually maximize the volume. So now you need to pull out your calculators, use your calculators to help you find the maximum volume of your function. And F, what is the side you need to cut out to actually make that maximum volume? So this is actually finding the x value for the maximum volume. And so for E, you're actually finding V, and then for F, you're actually finding X, different parts. Now the next part about your project is a little more complicated. It deals with our cylinder, and so I give you the formulas for a cylinder. This is our volume right here. Volume is pi r squared h, and this is our surface area. And so then we can find the surface area. We want to find surface area and volume if we know a regular tuna can. You actually went to the store and bought a tuna can, which includes like chicken and beef. They have a lot of different meats now that are in the tuna can package. But if you know a radius is that value and the height of a tuna can is that. So they give you H and R. So you're going to plug these values into your two equations up here. So plug these into your equations to find what V and S is. So we need to know the numerical value for what the volume is of a tuna can and what's the surface area of a tuna can. And we're going to use those in the next part. So this kind of gives you some hints on what you're going to be getting here. So here in A, we're just writing down the formulas from the previous portion, kind of starting with a base value there, just the variables. B, we're going to substitute the surface area value of the standard tuna can, so what you just found in the previous problem, into the surface area formula. So you're going to actually put in the number for surface area and leave the rest variables. So whatever the number is, and then equals, and then you're going to have 2 pi r squared plus 2 pi r h. Kind of review of surface area. This is double our base area plus the area of the outside, which is the circumference times the height. So we can solve this. This is going to be some number right here. We have to put in the actual number. Solve the surface area equation for h. We're going to isolate h in that formula. Then we're going to substitute h into the volume formula. So this is how we're creating our equation. We're taking two different equations, your volume and surface area. We'll substitute the h into the volume equation. So now we're going to have one equation that deals with volume and radius. We can find the real world domain of V. What could our H value, or what could our R value be? What makes sense? And then this should be F really right here. So then we're going to maximize the volume of the tuna can. So what we're really doing here is using the same amount of surface area. What's the biggest amount of volume could we create? Are they really maximizing the amount of volume with material they're creating in the tuna cans? So we can simplify the equation and maximize it like we did in the first part with the prism. And we're actually going to use your calculators to maximize that. The maximum, we're going to find that radius and the volume that maximizes that situation. And then in part 5, we're going to sketch, we're going to list the different dimensions of both a standard tuna can and the maximum volume tuna can that we actually just created. And then you're going to sketch these. These sketches should resemble or show the differences in the dimensions. So when you list your dimensions of each can, make sure your sketch reflects those dimensions that are different. And then 6, why do you think the tuna fish companies do not make cylindrical tuna fish cans with the maximum volume shape? So you can discuss that on your own, what you've learned. And then the bonus is kind of working backwards, is saying that if we know how much of volume we want to put into that tuna can, let's minimize the actual surface area. So I'm not going to give you too much help here on our bonus, but I want you to think about how you're kind of working backwards in the substitution to minimize the surface area formula. So think about how to set that up. So that hopefully helps you start the project, go through the different parts, go as far as you can in the project on your own here. You're welcome to text me again if you're stuck, and then on the next day at school you can ask more questions, hopefully to help you keep getting through the project and finish it up. Have a great night, and we'll see you soon.